There's going to be a 2 million engineer deficit in a couple of years. Should be okay. Contrast security. So I'll be there which is great because it's small enough that I can still correct and code.
So that's unicorn jump.
Yeah, so well, and I like honest to God, I would much rather code rather than managing code. But
Yeah.
You know, those, I just my coding chops are so rusty at this point. I don't truly think I can provide the sort of technical vision that a company like Contrast needs. So that means I'm going to have to hire a really badass senior engineer.
I just remember we did that.
Oh yeah?
Yeah.
I love that. So Robert Reeves and I worked a lot together when he was just getting the whole thing started.
Really?
Yeah.
They just celebrated their 7-year birthday for my first high school.
Well, I can't believe that they haven't even speaking up.
So yeah, we just had a round C.
I'm really surprised. They're the only branded solution that I can think of for data index. They're the only one I can think of. I mean, now they're based on liquid based. There's Flyway, which is based on Python 1. People out there, the Flyway isn't a company; it's just it's an open source technology. Cataclysm, you get a throat to choke. Which is what big companies do.
Rio's Nathan Box, we got a broke Nathan Box working.
Oh yeah. Well, I mean, it's actually a really common pattern. You've got a really good open source project. Wow, they're a kind of funny you wouldn't believe it. Yeah, it's really common pattern, especially yeah, I remember looking at it. I remember looking and getting the honest. Yeah, so,
And really well with that.
yes, and we were nimble.
Yeah. I'm going to talk to Robert. One of our assistants.
So anything that has to do with let's make data more like DevOps is, in my mind, data is the only truly remaining unsolved problem. Security is still unsolved, but it's come hard now. That's DevOps and all that. But data is still, in my mind, the truly unsolved problem. All right. Yes. All right, if I can call y'all to order, get the housekeeping done, and then we'll get the Microsoft thing happening. There are a bunch of strange faces in the audience because we have a Microsoft topic tonight. Eric Jackson being one of the strangest. Good to see you. First of all, a few things to know. DevOps days. I'd love to tell you to go get a ticket right now. We closed the waiting list. So you're too late, sorry. By earlier next year, that's all I can tell you about that. I just found out that in May 28th will be the Percona Live. You really care about this. The Percona Live data will be here in town. Percona is one of the premier data consultancies in the world. Peter Zaitsev, one of the founders, is the guy who essentially was the MySQL liaison to the NODB team. So he worked directly with E.T. Curry to create NODB. And from that, they've branched out to MongoDB and all that stuff. But Jeremy Zawadny, Baron Schwartz, all those guys work there. They're the ones that wrote high performance MySQL, yada, yada, yada. And they have a massive team now. They are a great company. So that's a very data-driven type thing. And they are very DevOps aware. Percona is. So I think I saw prices from like $300 to $500, but it's here in town. So that's a cheap ask as far as that goes. So if you're into data, if data is a thing for you, if you're still managing the relational database or the document database that's out of control, you'll probably get some great information at that. I know I'm going to go. I already asked my new boss, hey, can I go to this? I'll pay. I believe it's May 28th at the AT&T Center. The Texas Scalability Summit, which is Lynn Bender's answer to DevOps Days, he is going to be running that on September 13th. Tickets right now, I believe, are still $225. But and what he does is they go up throughout the year. He starts really early, and that's what helps him keep his staff employed as he's between conferences. So you'll get a really good deal on that. The speaker list is already shaping up to be amazing because Lynn lives right in the middle of San Francisco, and he knows everybody. So you're going to see an amazing, that speaker list will continue to grow, will continue to be amazing. If there is somebody you'd like to see speak, like you want Patrick Effing Dubois, well, he's coming to DevOps Day, so you probably don't want him. But if there's somebody you want to see speak, somebody from New Relic, somebody from MongoDB, et cetera, et cetera, et cetera, let me know. I'll give Lynn their name, and he'll go find them because that's Lynn. So that's kind of cool. So again, if you're looking for more, more of a conference type setting, I expect that to be of the quality of Day-to-Day Texas, which I've also found to be an amazing deal. He has announced Day-to-Day Texas 2020. That site is up, which means tickets are the cheapest they're going to be. So if you work on or near the big data space, now's the time to buy the ticket for that as well, because it'll be at its cheapest. That's in January of 2020. Okay. So anybody else have any? LastCon. I'm sorry. Lone Star Application Security Conference. LastCon will be. I think it's end of October this year. It's like the first week in November. Again, phenomenal local conference, all about application security. Come and meet all the paranoid peoples, and make sure your cell phone's Bluetooth is turned off. Great conference. I've been there. I've been to that one 3 different times, and always walk away thinking, There's so much I don't know. So, you know, if you want to broaden your horizons. Any other conferences going on in the Austin area that, no? Everyone see the pizza? Okay. One more announcement. Typically, we would go back that way to get sodas. That's good. But you can't go all the way to the bathrooms. They had that locked down for some reason. So you have to walk out this door. Well, walk out there. So don't bother the speaker, please. But follow down that hallway like a rat in a cage. Just keep your left hand on the wall, and eventually you will get to a bathroom. Please check the gender. They haven't, you know, like gone all, you know, whatever it is, do, you know, half a skirt or whatever the new symbol is. So there are still gender-based bathrooms. Go there, do that. All right. Let's see. All right. If you have a job that you are trying to hire for, if you're a hiring manager or you're an engineer whose hiring manager said, please go find me a DevOps, please stand up. If you're a recruiter, you may also stand up. Please just give us that one job you wish you could fill, not the 20. So, anyone? Eric?
We have two SRE positions, one Linux-centric and one Windows-centric. There are three senior and staff level positions. So they haven't been posted. They're not on the website. So just come and see me afterwards. But we're looking for people that think a lot of DevOps people.
We're getting to the likes of you and Byron and Carl.
Carl works there. Byron works there. I work there. So if you like the way that Boyd and other DevOps people think, that's what we're working on. And our manager actually gets it, which is why
I work at a company called Blue Cats. They specialize in IoT location, beacon, UWB, GPS. Cloud team looking for people who specialize on AWS. So if you're into that, you just come see me. Job description, contact. What part of town are you guys in? East Austin.
Nice. Man, did anybody hear IoT and start doing this? I would love to get my hands on, you know, machine data at the IoT level. That would be cool.
Well, that would be the initial goal. At the moment, it's like building up the cloud platform, a localized version, hardware, this is hardware. So.
Are you guys actually producing widgets?
Yeah, it's international conference. We have our manufacturing center in Huntsville.
Huntsville, Alabama? Okay, very cool.
Not for the prisoners.
That'd be
kind of sad.
Hey, my custom bicycle was made by the prisoners. Well, not where, but near there. All right. Is Alien Vault not looking? Or are you just like?
AT&T is currently preventing us from hiring all the people we need. But
you know, that's a. You need to work on your marketing skills, Douglas.
If I was talking to strangers, I would. But in this room.
Okay.
Right?
Friends don't let friends work at AT&T. Is that what I'm hearing?
We need people. We know we need people. We're just not allowed to hire people this month.
Very good.
You said that. Now
I'm going to get in the shower.
that's a big trick. Oh, that's for Saturday.
Let's see if we're actually sitting there.
That's why. Which one is the 28th?
Yep. We know that guy. I will be taking a job with Contrast Security as their cloud operations director. Allegedly, I will have an open rec for a senior person when I join. So if you are looking for a gig in AWS to work with a very forward-thinking company in security, you can come and talk to me now. But I won't even have dry ink on paper until Wednesday or Thursday. But it's all the virtual handshaking is done. So let me know. All right, now if you are looking for a job, please stand up. You are. Mr. Chris.
My name is Christopher Stevens. I specialize in that, Linux, Python, all those fun fuzzy words I could say. Been doing it for about 10 years or so. Live in South Austin, looking for a gig that is either remote or South Austin or somewhere around there. But I'm open. I'm open to A+ opportunities. So anyone wants to talk after that?
I'm David Witzer. I've been in Austin for like 5 years or so. I don't know what I want to do, but I've been doing cloud professional services, cloud architect stuff for a company called BXC Technologies, which you've never heard of, but they're like CSC plus HP plus lumbering dinosaur company. Nobody hears from there. Okay, good. So I want to make a change. And that's it. I live in Cedar Park, way south Cedar Park, so drive to downtown.
Oh boy.
So, sorry. That's pretty much it. So if you want to talk to me,
Outstanding. Anyone else looking, or so we're not recording yet, as long as your boss is in the room. All right. There are recruiters in the room. They didn't stand up. Please, yeah.
I'm Claire. I'm going to go back, and I'm with that system. So I like to introduce myself, but I know specifically with the one position in order today with Azure, I do have one position to see the ICT aspect in an Azure environment. I'm looking to either with Azure public cloud too, but so if anybody wants to hear more about that.
Thank you very much, ma'am. All right. Other announcements? Anything else going on in the community that folks should know about? All right. Make sure you check out Cloud Austin this month. They run some Kubernetes on their meetup, so you're going to want to go there to touch the Kubernetes. Right? What makes a meetup better attended? Food or Kubernetes? Not sure.
That's hard.
Indeed. Indeed. Speaking of food, the pizza, which was Roppolo's of all things. Roppolo's was a food truck before there were food trucks, people. They've been in Austin, well, since I've come to Austin. So that's like street pizza in downtown. That was brought to you by Plotins through the efforts of Sean back here. Thank you very much. So, when you're, as you're wiping your mouth and all that savory grease, give Plotins the look-see. See what they do, see if you can use it. Our host for the last 5-ish years now in Rackspace, we are coming up on year 7 in July. So Rackspace has the Rackspace Cloud, if you don't care. Rackspace also has fanatical cloud support for every cloud, GCP, Azure, and AWS. So if you need cloud services, MSP, et cetera, I'm not saying you owe Rackspace your business. I am honestly asking you to simply give them a chance or influence your boss to give them a chance. Even though they're a little more expensive than most, when you sit down and think about what they're offering, I think you'll find that you get what you pay for is really in play there. Finally, Austin DevOps next month will not be a talk. It will be a set of tables. We're going to run a micro conference, which will basically be a DevOps Days Redux. So if you're going to miss DevOps Days for whatever reason, and you were like, God, what went on? Every May, we always do that. So what we'll have is we'll set up a micro conference of what people want to talk about at a given table. Every now and again, somebody does a tech talk, but usually it's more of the more of the open space type thing. So if you want to prepare a tech talk for that, feel free. You just have to pitch it, and people just need to show up. We'll make sure you get a screen. So if you're interested in that format, you want to know more about it. We are programmed for June. Chris will be doing a talk with.
Oh, geez, right now?
No. Sorry, you'll be doing a talk. And I've already got. Carl Katsky will be the other half of that. Will be the other half of that presentation. But tonight, I can't tell you how hard I have to work to get Microsoft content. Now, I'm not a Microsoft guy. I mean, every time I have to touch a Windows machine, I get sad. It just shows me how stupid I am. I'm not a Microsoft guy, but Microsoft matters. And ever since Palmer left, and they were like, "Oh, look, open source." That's cool. The company has been amazing in its contributions to the technical community. So I'm happy to provide Microsoft Windows, not so much Microsoft content, but the ecosystem, Windows, Octopus, Team City, is it Team City? Is that right? Although GitHub now, right? Et cetera, et cetera. If there is something you want to say, if there is something you'd like to learn, and you can let me know, I will go looking for you, I promise. I think the reason we've had such a dearth of it is I don't know where to look. I don't have that network. And so when people fall into my lap, like our speaker tonight, I always say, yes, please. Or when Eric Jackson decides to grace us with his presence, I'm like, oh, yeah. All right. So without further ado, we have a great presentation from Jeff. Is it? Palermo. I've been saying your name. I was saying it.
You know Spanish? You know my name?
I was missing an E. No, I grew up in North Dakota, dude. I speak Canadian. So, come on up, Jeff. Thank you very much for making the time. He has handouts.
Because some of you will probably want to grab one during the presentation. If you know you have poor eyesight, just go ahead and grab that to help you out. And while I'm just introducing myself, while y'all are going and getting that, I'll show you something. This is what I'm coming off of over the weekend. Aircraft. Side share that. Break the ice a little bit. All right. And yes, the gun's adjusted, but they did not shoot. Just roll them up and down. All right, let me close this down. All right, there we go. There we go. I found this website called infinitelooper.com, which you can paste in your YouTube URL, and it'll just loop whatever YouTube video that you want. Yeah. Okay. Over a year and a half ago, I think, I also started a new user group, which from 2005 to 2010, I ran the Austin.NET user group. Now, since handed it over, it's still going well. In 2006, I was on the founding board of the Agile Austin user group, which is still going strong. I was the founder of the Azure Austin user group, which is not going strong, but it's going.
Can I interrupt you for a minute?
Yeah.
I'm sorry, I forgot a very key announcement.
Okay.
The
Go for
Azure
it.
Austin DevOps thing has stopped. And it's a version of this that meets at lunch every month. They need somebody to run it. So if you're interested in running a SIG, special interest group, for Agile Austin and all the, and all the support that they give you, please let me know and I'll introduce you to Will Simpson. Sorry to interrupt you, but when you mentioned Agile Austin, I was like, oh, we're missing a piece. Thank you.
Yeah, I just lost my train of thought. So I guess we'll wrap it up here. You've been a great audience. And so I took a little bit, about a year hiatus, and a year and a half ago, I started a new user group called, at the time, I called it the Microsoft DevOps user group, and you can find it on Meetup. And then Microsoft completely changed all of their branding and launched this new sweet product area called Azure DevOps Services. So I just renamed the group. Okay, we'll be the Azure DevOps user group, meaning, hey, we're the people who are kind of targeting Azure, and we're doing all kinds of DevOps stuff and learning what that means. In general, shipping software on the Microsoft platform, DevOps group. So now that group, after about 3 months, we got so much interest outside of Austin that we went completely cloud. So it's a complete virtual online broadcast, everything. So there's actually some people from that group, because I pressed the button, listening right now. and they're listening. I'm kind of webcasting it through Zoom to them. I press the button and all that, and so they're on there. So if you ask any questions, make sure they're really awesome questions, because we're going to record. I'm just kidding. Ask any question you like. Well, it'll enable this to be recorded and posted online, so that if someone didn't come tonight, then you can also share it with however you want. And we'll trim the beginning, and there will be no announcements. It'll just be kind of the beginning of the presentation and the end of the presentation. So that's how we'll go. So again, my name is Jeffrey Palermo, and I am a longtime consultant. I have a software engineering company called ClearVector, which is headquartered here in Austin. But of course, we're spread out. We're spread out all over the country. Have actually way more people not in Texas than we do in Texas. And I'm the chief architect and also the CEO. And our vision for the company is to really help software teams be world class by enabling them with DevOps processes and methods and tools, and helping them through hard projects like modernizations of aging legacy systems and project jumpstarts of projects that they've never done that type of scale before. And our focus is Microsoft platform through and through. Let's see. If you ask a really good question that stumps me, I've got 2 little giveaways today. This is a sample chapter that we got printed up of my DevOps book that comes out in May. And the name of the book when it comes out is .NET DevOps for Azure, because it'll all be all about, okay, how do we do software really well if I'm completely on the Microsoft stack. Now today, the thing that we're going to focus on with our lens on all things Microsoft, and by the way, all those icons and everything on those posters that you have that you can with a really small print. And by the way, if anybody wants a PDF, like where you can get it printed out, just send me an email somehow, and we can send you the high-res PDF. That's perfectly fine. But every component is, we're going to be talking about which Microsoft tools and technology and technique kind of fit in as we're going from having an idea to monitoring and observing people using the working software in production. So that's that. So why don't we jump into it? And my audience for this presentation is a software leader. Okay, we have a mixed audience, and that's always the way it goes. But DevOps is about enablement. It's about making a team shine and making things go really well, shortening cycle time, automating everything that can be automated, squeezing out defects, and enabling a team to be truly world class. So there's just a bunch of techie stuff that goes into it, but that's what we want to do. Lower the drama, increase the awesome. Okay? All right. So a little bit about me. I'll have this at the end as if any of you happen to have a smartphone that happens to have a camera on it, if any of you are in that audience that fit that profile, and you want to take a picture and tweet it at me, it's at Jeffrey Palermo. I'd appreciate that, because I forgot my tripod with the photo with the remote so that I could just click it all throughout the presentation. I've never done that before. Okay, so you're a software leader, and everybody in this room probably has a member of the team that's more junior to you. So you're guiding someone, and you may not be running the team. Some of you are running the team. Some of you are running multiple teams and big teams. But ultimately, we don't want slow. We don't want weeks and months of releases. We hear about these companies that are releasing many, many, many times a day. And if we're not already there, we think, okay, why can't we deploy on a moment's notice, stable software, end-to-end, every single one of our systems? And maybe even if we have some of our systems that are there, we look at these, maybe our legacy systems that are not there, or maybe just the web application is there because we're just copying files, but the database isn't there because maybe the company still has the database department, and we have other processes around there. So we want speed, okay? And I'm going to talk about the relationship between speed and quality in just a minute. And I want to get through and set your worldview before talking about the actual technologies or tools in detail, just so that we can get our minds all on the same page. So what slows us down? We have some symptoms. You can read them on the screen. Error-prone deployments. Has anybody had an error-prone deployment? Come on, show me the hands. Absolutely. Delays, lead times, and unmitigated risks. This is one where a lot of managers or teams don't talk about what risks might be there that are completely unmitigated. Does anyone have a friend who has an uncle who has a cousin who might have restored a production database to a pre-production environment, including every column, including PII fields and things like that? Right, those environments don't, so think of it as a risk, right? We don't want a data breach. So what are we gonna do? Let's get everybody's social security number into an environment that's not protected by production controls. But gosh, it's kind of the dirty secret how many organizations have somebody or some team that kind of does that on a regular basis. And so when everything's manual, you're like, well, shoot, how do we get a representative data set into a non-production environment so we can even test? Well, in a completely manual world, you're just trying to survive. But when you automate everything, now you can say, oh, wait a minute. We have that automated data pullback routine. Oh, but we can put some products in there. We can put a data mask or a data clone. We can expunge some certain columns, or we can generate some data and have other automated processes so that we don't have to put ourselves at risk. These are just symptoms, by the way. There are root causes. And the first one, biggest one, is an insufficient work environment. And that's a huge topic in the DevOps community. It's the question, what is a complete DevOps environment? What stuff does it need to have? And what stuff is just kind of software architecture, patterns, you know, the way you code? What if you have a DevOps environment, what does that mean? What do you have to have in it? We'll talk about that. Okay, let's talk about a big challenge that we're all working on in our industry. This is from last year's Stack Overflow survey, and look at the percentages. So if you are 0 to 5 years professionally in programming, you make up more than half of the working industry. Okay, it's not because us old guys, and I'm on year 22, so I guess I can call myself the old guy. But I mean, I have people at Clear Measure. I celebrate. It's like, oh, you topped 30 years in the industry. That's awesome. But we haven't had a big exodus of experienced, 20, 30-year people, but we've had this massive explosion of new people coming into the programming field, which is fantastic, okay? But let me add on an analogy to color that a little bit. Okay, so put yourself in an auto mechanic shop owner's mind frame. You want to start an auto shop, mechanic shop, and you say, you know what? I'm going to do this right, and you get a great location on a good road. You build a brand new building, beautiful building, and you call up Snap-on or wherever you get tools from, and you say, give me this equipment, give me these tools. You buy beautiful equipment and tools, only the best will do. You go to the local auto mechanic school, trade school. You talk to the dean of the school. You say, you have a graduating class coming up. I want to hire the top of your class. I want to hire the top 7% of your class. Only the best will do. Really smart, sharp mechanics, top of their class. I'll pay them what it takes. And so that class ends. You get most of that top 7%, and they're coming in. You have everybody gathered in front of the building with the beautiful equipment set up in shrink wrapped in crates, ready to go. And you give the pep talk, and you're all excited, and they're excited, and you say, okay, we have a few days. Let's get ready for the opening day. I think we have 2, maybe 3 days, and we're going to open. All right, team, get ready. And you kind of walk off with pride, and your crew, top 7% of their class, is looking at each other wide-eyed with fear because they were never taught how to set up their own environment. They were taught at the school with a professionally set up environment. Okay? So that is one of our big challenges here in the software world, with over 50% of the people working in the industry with 5 years or less. Really smart people. But how many of you in this room, because I think that there's a lot of people in this room with over 5 years experience, how many of you, raise your hand, were taught in your formal education how to set up your environment for yourself? My hand's not raised. Anybody? One? Okay, most of us were not. Most of us learned along the way what it took to have an effective environment. And with the DevOps conversation, the industry is still learning what it takes to have a complete working environment to be really effective, okay? And the tools will be different for Java, Python, C#, Node. The tools and libraries will be different, but the concepts are largely the same, okay? So let that color the rest of the conversation. Now, there's so much about DevOps that's quality, so I want to throw this research in. And you can look up this research from Capers-Jones. I believe the article is Software Defect Origins by Capers-Jones, and you can Google that, and there's a PDF. And this is taken straight from there. And it's basically for every 5 defects, this is how many come from these different areas. So for, wait a minute, no, it's converted. For every 100 lines of C#, it was converted. So for every 100 lines of C#, there is going to be 2.21 defects on average that come from just problems with the code. But there's going to be defects that come from bad requirements, analysis gaps, bad architectural decisions. Look at the bottom, bad fixes, trying to fix other things. So when we look at quality, when we look at problems, things that could go wrong, and if we only focus on code, as in you can only have a bug in code, then we're kind of short-sighted. So as we look at our DevOps environment, yes, code's important, but we need to look at the full assembly line, if you will. And it's and lean manufacturing, Kanban show that imagery of a pipeline. And in DevOps, we call it a pipeline, but the pipeline doesn't start at source code. The pipeline starts when somebody with money has an idea, okay? And then they fund, and essentially they pay somebody to, hey, you know what, let's put this into software. Somebody with money has an idea, stakeholder, product owner, executive at the company. They have an idea, and then it flows through a series of different types of work. And if you've read the Phoenix, how many people read the Phoenix Project? Okay, so you have a plant of workstations that each do something, convert the inventory into the next work in progress, and then a series of workstations, and boom, you got working software. But it doesn't start with code, it starts with the idea. And by the way, there's some research in Scrum which shows that I think it's called the law of thirds. About a third of the ideas that a product owner has are going to meet the objective. They're going to be great. They're going to do exactly what was expected. About a third of them aren't really going to make any difference once you actually get it out to production with the users. And about a third of the ideas actually made things worse, and you want to back them out as fast as you can. And so with that learning from the Scrum community, with the product owner being, how many people have used Scrum at any point in time? Anybody? Okay. The product owner said, hey, the product owner has ideas. The product owner is the one that prioritizes what we do because the product owner knows everything, right? But the product owner's track record is a third, okay? So from a DevOps capability, what happens to the third that made things worse? We need to have a really short cycle time so we can back that thing out fast. Okay, if we have a slow cycle time, well, it's going to be another month before we can put out another release that's going to actually undo the harm that we caused. That doesn't work, okay? So let's talk about the conventional view of a DevOps environment. Now, you've all seen that sideways figure 8 with the DevOps thing. I have no idea how that thing came to be so popular when the main thing of DevOps was, hey, let's break down the silos and make one team. And then we draw a sideways figure 8 with a process around dev team, ops team, and let's just go hand off between the two. How did we do that? I don't get it. I don't like that sideways figure 8. And I actually, the agile mindset, and definitely Scrum really pushes down people's throats, is one team, cross-functional, everybody together, whatever skills you need, get them on the team. Well, that's the DevOps message too. So we should really just be one cycle, right? One cycle, not this figure eight around two different competencies. If we need all kinds of skill sets, great. Let's get one team, let's get the right skills on the team, and let's rock and roll. Okay, so plan, code, integrate, package, release, operate, learn. Those are essentially what you need to do, and you need to be able to have a fast cycle time. And in the middle, you have this automated DevOps pipeline. It certainly is the hub. It certainly is the enabler. But I made that really small. That's not everything. It's a piece of the puzzle. Let me drive through a few more layers that are really important. The practices you choose, how you choose to remove defects, team workflow, architecture blueprints, and cloud operations. You could call it operations, but in today's day and age, everybody's moving to cloud in some way. So there's more things to it. And I want to just touch on these because as a leader, when you are organizing your team, when you're thinking about these things, every one of these represents some decisions you have to make, some things you have to do. And of these layers, each must have a really sound strategy, be executed with discipline, and have objective measures. And it's not enough to say that you've equipped your team with defect removal, for example. Your strategy in that area is the selection of defect detection methods. And so I'll talk about Capers-Jones a little bit more when we get to that. But the sound strategy takes out the guesswork out of the process for the rest of our team. So as a leader, we need to think, okay, how are we going to do this concern? Strategy is short for a plan. So let's quickly touch on the layers. And for each of these, I've got a beginning state that if you don't even think about it, what your beginning state might be. And if you've thought all the way through it already, you might be on the ideal state. And then on the left are some options. So with best practices, guess what? There's tons of practices that have been labeled best practices, meaning, hey, they're really, 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 really good practices, but there's too many. Not a single team, not a single project has implemented every best practice that's out there. There's just too many. You have to select which best practices are appropriate for your situation, okay? And so one example practice commonly selected and known to actually reduce defects is build versus buy, the selected use of stable, reusable components. And on the Microsoft stack, it's NuGet packages, corollary to NPM packages. NuGet packages, every library under the sun you can get from NuGet.org, and instead of building your own components, the libraries, you can grab those components, and that's great because it cuts down on the custom code to use. Now, on the corollary, a top 10 cause of defects is the unapproved and unknown reuse from these package managers, where the rest of the team and the team leader doesn't know that somebody went to NuGet, grabbed a package, stuck it in the software, and now that they're using it. Now, there's great and well-known and proven stable NuGet packages, but there's also NuGet packages out there that were just kind of published by somebody and have maybe 3 downloads. Do you want to be the 4th? Now, just to be honest, I have a package out there that's published in NuGet publicly. Y'all can go and use it. Doesn't have much usage. Therefore, is it really stable? Has it really been hardened? And is it defect-free? No way. Heck no. Stay away. Do not be the 4th download. But that's a top 10 cause of defects. So let's keep going. All right. So the next one is defect removal. You need to think. As a leader in your team, you need to think about what strategies you're going to use to control defects. Because again, you're putting this environment together, this assembly line together. That's the goal is to squeeze out a layer of filters to squeeze out and find problems before they go to your users. And so I think I mentioned the white paper, Software Defect Origins, the full title, Software Defect Origins and Removal Methods by Capers-Jones in 2012. But, on the left-hand side are really good, yes, sir?
I put a link in the meetup.
Oh, sweet, awesome. One of the, on the left-hand side are a lot of possible techniques. and you notice that pair programming is listed. Pair programming is actually really, really effective at preventing and removing defects. I think one of the reasons that it's not widely used is because it's also almost the most expensive method, because it doubles the cost of everything. And so when you look at the methods, you go, okay, what are we actually going to do? Because hardly anybody actually does full-time pair programming. To get to a hard problem, okay, you bring over somebody. But the cost versus the reward, the return on investment, there's 3 of them that are supported by research. And actually, this doesn't matter if you're slinging C# or anything else. The 3 defect removal methods that, if you put them together, get you into the high 90s according to research averages are, and you want me to tell you, don't you? I'll tell you. So it's inspections, testing, and static analysis. So static analysis could be any one of, JavaScript, linter, independ, SonarQube, ReSharper, the built-in Visual Studio analyzers. That's static analyze. Any tool that you can run against the source or even documents. Microsoft Word spell checker is a static analyzer. I mean, you have a tool and it looks at stuff and it finds potential problems. Okay, tons of them out there, and once you add it in, it just runs automatically and you get constant benefit from it. So in the category of static analyzer is anything that can run against your static assets and find a problem. So a linter definitely is a static analyzer. And yes, the creating metrics out of the code, those are static analyzers. It's any tool that you can find that'll look at your source code, documents, ARM templates, Terraform, PowerShell scripts, anything that you would put in your Git repository and find a problem. That is a static analysis tool. All right, then there's testing. And there's a hint of it on the poster. We'll go into detail, but 3 types of testing is bottom of the barrel, ticket to the game. One is unit testing, where you have tests that call code that does not call out of the current memory space. Those, by definition, they're going to run in about 50 milliseconds or less, 50 milliseconds max. A lot of times a lot faster. But anything that's taken more than 50 milliseconds, either is doing a really long loop or it's calling out of the current memory space, and it's not a unit test, okay? So unit tests do not call out of memory, do not call out of the current process that it's running in. Then the next level is component level integration tests. They do cross a boundary line, and they're meant to make sure that two different pieces or components of the application can work well together. Really common one is your data access with the relational database, to make sure that the code that's exercised in the data access layer, round trip to the schema of the database, come back across the network, and that's a good type of integration test. The third one is full system acceptance tests. Those are tests that have to rely on a fully deployed instance of your application and then execute it from the outside in, kind of like users would do it. And so Selenium is probably the most common tool that you would use for C# web applications, and then just run it with an in-unit test suite. Those are the 3 types of testing, and then inspections. And we'll talk about this a little bit later, but the perfect place for your inspections is going to be your pull request process, where you and your team can specify what that checklist is. And just like anyone who's building something has inspectors. There's apartment inspectors, there's residential housing inspectors, there's commercial building inspectors. And when they go in, they don't look and say, oh, I like the way this code is. Yep, I would have put that ceiling tile just like that. But I've seen people do that when they do a code review. Oh, this code looks maintainable. Yes, approved. No, they have a checklist. All right, there's all kinds of standards. And so a formal checklist in the pull request would be whatever you decide, all these different things. And the person who hits approve says, I, state your name, on my honor, have looked at this set of changes on this feature branch on every category that's on this inspection checklist, and I don't see a problem with any of these categories. Approve. That's an inspection. That's a perfect place to put it in. All right. All right, so, but either way, if you're thinking about the effectiveness of your team, you need to choose which defect removal methods that you're going to put in place and make sure that they're executed, because you're guaranteed to have defects. If you have a 500,000 line of code system, you're going to have thousands of defects come up along the way. The question is, does the DevOps process that you have end to end catch 99% of them? Or are you shipping hundreds or thousands of defects to your customers? Now, granted, they're not all going to be showstoppers. They're going to be defects. So you got to think about this. All right. The next thing is team workflow. And I've got some diagrams a little bit later on. But you need to model your full workflow. The online project tracking tools were probably set back. The online Agile project management tools probably set back the Agile movement for years because they constrain you to your 24 or 30-inch monitor, however you may be doing it. Before those came about, what did they say? Go find a wall. Go find a whiteboard. Use sticky notes. Who did Agile? Who's still doing Agile? Right? Well, we all are if we're doing DevOps, but it was sticky notes, right? The original was sticky notes, Post-it notes, no constraints. And so people who really made it hum and really got fast, they were using the entire wall because they figured out all the different, going back to the Phoenix Project book, they figured out all the different workstations that were necessary in their process, all the way at the beginning where an idea came about, and all the way through to when the users were using it. And they found that they had much more than just not started, in progress, done. And they used up the whole wall. All the digital, whether it's Jira, whether it's Azure boards, Pivotal Tracker, any of them, when the columns start giving you a horizontal scroll bar, doesn't it make you want to remove a column? Just doesn't it? But no, if you're really thinking about how big is our process? I mean, if you have 2 people, then maybe you combine some things. But by the time you have, I would say, by the time you have 8 programmers on a project, you're going to have all kinds of people upstream from the code and downstream from the code. You got a serious project going on, and those swim lanes are not going to fit on one screen without horizontal scrolling. It's just not going to happen. But you need to model your entire workflow, okay? And choose what the process is, and make sure that you don't have any unspoken parts of the process. Remember, what's the first way of DevOps? Anybody have it? Flow. And the first principle within flow is make work visible. Okay? It's okay. What is the work? Well, that's our swim lanes. Every type of work, boom, gets another named swim lane. That way, we have an opportunity for all of the work to be visible. Here's another, you can go back to work tomorrow and you can just ask yourself this question, ask your teammates, say, hey, you know what? Let's just not have our email open during the day. Any work flowing through email instead of through your project system? All the time, right? Well, guess what? We're making some work hidden because we've got it coming from email. We got it coming from Slack, from our chat, from Microsoft Teams, go and plug in Microsoft, and we got everywhere. Work is coming, phone calls, sticky notes. Your boss comes by and says, "Hey, Peter, can you come in this weekend?" Right? Any office space? Okay. I know it's late. Pizza, nap time. All right. So the next one is architectural blueprints. All right. Now, whether you're a member of the team or whether you're running a team, every single person on the team has a mental image of the current shape of your software system and what the shape of the software system should be next month, next quarter. And unless you're looking at the same diagram, I guarantee every single human has a different picture, has a different mental model of what it should be. Because without a shared actual picture, we're all trying to create this picture for ourselves because we need the picture, all right? So to enable your team, to align your team, make sure that you actually have the picture. Now, it doesn't have to be in Visio. Visio's great. It doesn't have to be in Visio. If you've got nothing, go go draw it on the whiteboard and snap a picture with your smartphone and boom, okay, great. That's what it is. And then in 1995, a guy named Philippe Christian from Rational Software created an emergent agile architecture framework. And I think that that's probably, to this day, the best architectural model. And you probably want to Google and say this too. It's the 4+1 view model of software architecture. And he calls it software architecture blueprints, okay? And we use it at ClearMeasure. We use it for every project, whether we're going in and figuring out how to modernize this legacy system and trying to figure out how it's shaped. You spend 2 hours with the team. Okay, let's draw this thing. First of all, how many servers is it running on? Second of all, how many processes are running on those servers? Okay, now what's running in those processes? Okay, so if I hit this button on this UI, how does the data flow? I mean, we gotta kind of harvest this knowledge. How many people started a new job in the last 5 years? Anybody? All right, the first few days, you ask, okay, we got a software system here. How does it work? That's kind of what you do, right? It's like, well, and how many were handed up-to-date, layered software blueprints that you can kind of print out and look, say, oh, okay, I get it. Any hands?
How many of you have ever seen it?
Right. So we've heard that these exist, and a few people have seen them out in the wild, but software architecture blueprints are definitely an endangered species. So the 4+1 view model of software architecture is a model for emergent iterative architecture, okay? And it's probably still just the best framework because it's so simple. Here's the gist of it. You have 4 layers, and then the +1 is your scenarios or use cases that kind of illustrate how the 4 layers are connected. And if you've ever built anything, by the way, anybody who builds things has a drawing of what is to be built, right? Even if it's a storage shed or a big house or a building. So in building, in civil engineering and building, you've got the floor plan, you've got the structural foundation, plumbing, HVAC, electrical, the network view. I mean, whatever view you need, you've got another layer of these blueprints, right? Multi-layered blueprints of the same thing, and you put them all together, and okay, now that makes sense, I can understand the whole. Same thing with software. And so the 4 layers are the physical or runtime. And that is, okay, how is this thing going to run? Is it all going to run in one process with one memory space on one server? Or are there different parts of it that are running in different processes on different servers kind of hooked to each other, okay? That's the physical layer, which in 1995, it was all physical servers, so it's physical. But just think runtime, okay? Runtime, how's this thing going to run? And then the second layer is logical. Okay, we're thinking modularity. Yes, we could probably have 2 runtime instances of the same website, it's a web farm, but logically, we have a website. Logically, we have a back-end job. Logically, we have a relational database, and we may have many of those various building blocks. There's not an infinite number of logical parts, by the way. I mean, you could have tons of different web applications, some serving web pages, some serving REST endpoints, some serving file downloads, but it's still kind of a website, right? You could have a logical job that all does stuff. Some triggered by a queue, triggered by time, triggered by an incoming HTTP call. And then you have data storage. You have relational data. You have maybe JSON data. You have file systems. But it's kind of a data store. So that's logical. And how are those partitioned? And then the next layer is process. And that is what order, when transactions flow, what order does data go through the different logical pieces? So that's the closest to your flow chart, okay? In what order do things happen? Versus logical is, of all these pieces, what arrows are the dependencies? Which modules, which logical components depend on the others? And then the 4th layer is development. And that's when you start your new job. It's like, okay, how do I set up my workstation? I need to create this development environment. Do we have some servers for the development team? What do I need to have installed? All that thing, because there's a structure to a development environment. And then the +1 is the scenarios, the use cases. And what you do there is you list out the capabilities of the system and then annotate. That's a little more fuzzy, but +1 is what the capabilities of the architecture are. Because if you were going to create a to-be architecture of the system 3 months from now, that list of capabilities would grow, because arguably it's going to do more stuff. All right, you need to have architectural blueprints. Now the next is operations. So was anybody part of the big test-driven development, it's got to be testable movement? Where we're kind of all arguing, what is back in, what was it, 2005, 6? Test-driven development, red, green, refactor.
What are you talking about, test-driven development, the software running on the system? Or are you talking about like test-driven development for chef?
Oh, got it. You're right, because we're doing it again on the infrastructure side. But so regardless, testability of software has been a big property, right? It's got to be testable. If it's not testable, then it's all kind of spaghetti tied together. In the cloud world, the same importance now is around the word observability. If we have something running in Azure and we can't tell you right now what it's doing, how the heck do we support it, right? If we're depending on a user to log a trouble ticket, we're already sunk. So observability is making sure that everything that the software does is kicking off the right logs, the right telemetry, the right signals, the right performance counters, and then we're taking all of that, aggregating it together in a centralized location that's not in production, and layering on some automated queries with some thresholds, automated alarms, and a queryable interface so that we can kind of see, hey, what is this system doing? Oh, wow, somebody's been logging in over and over again. I need to go check that out. Is that just a kind of a coarse hacking attempt? Or, oh man, Jonathan forgot his password and he's gone through the reset password thing 6 times and he still hasn't gotten in. He's been trying that for 25 minutes. Let's call up Jonathan and help him out, or figure out why this bug is happening, right? I mean, somebody could be struggling, or yeah, somebody could be just trying some coarse brute force, hacking attempt. But either way, if we don't equip ourselves, our team, with the ability to know what the system is doing, we just think, oh yeah, well, nobody's reported anything, so I guess everything's great. And that's a bad assumption. All right, so we have to think about all these things. And in every one of these areas, we have to have a strategy, we have to execute it, and we have to measure. All right, it means we have to decide what we're going to do, and we got to do it, and we got to check up on how good we're doing it. Okay, and everything's iterative. So this right here, now I'm going to get into how we put together a DevOps environment, what Microsoft tools are linked together, and I'm sure we're getting closer to touching on that poster too. So this is the order, and it has a lot of previous concepts mixed together. Notice how the developer kind of writes some code in step number 5. Excuse me. So there are 4 steps of design before we can do any coding. Now, if you're in a team where you kind of in the same office space with your customer and there's 2 developers, you probably don't need much formality for this. But if you have a larger team, you actually need to think about, okay, who's defining the concept of this idea? You might call it requirements analysis. Who's figuring out what the heck this thing is, right? Then we need to come up with some kind of artifacts or process flowcharts, whatever it is. Then the second thing is, now that we know what the heck this idea is, and if we're actually going to spend any time on it and go forward, then we need to figure out how a human is going to operate on it, how a human's going to use it, what the user experience design is, wireframes, things like that. Ooh, thank you. I had water. Okay, so that's user experience design. Screen mockups would be a perfect artifact for this stage. And now it's like, okay, now it's coming to light. It does have a user interface versus maybe the component is completely headless. That's just under the cover job of a monthly report and email the report. Well, even if we're emailing a report that's auto-generated, what's a mockup of the report that should come through an email, that kind of thing. What's the human's experience with software once it was done? Now that we have that definition, next thing is technical design. is the current architecture, because you will have the blueprints, does the current version of the architecture support this new capability? Yes? Great. Does it not? Do we need to alter it at all? Does a new concept need to come into play? Maybe we need to rev the architecture given the new capability that's coming down the line. Do we need a new library? Do we need a new pattern? Any kind of technical decision that might need to be made for this new capability that's coming down the line. Make those decisions. Next thing is acceptance criteria or test design. Remember, four elements of design. Test design. This is the perfect spot for Scrum's acceptance criteria. That is, okay, we know exactly how this thing is going to look once it's coded. So now I know how it's going to look. How am I going to test it? What scenarios am I going to run it through once it's done to make sure that it was done completely and properly? And so we list out the test scenarios. By the way, scripted test scenarios, and it's only bullet points, by the way. Scripted test scenarios are the perfect format for acceptance criteria, all right? And so we have 4 types of design decisions that need to be made so that someone can actually put fingers on the keyboard in Visual Studio, sling in C#, and actually make this happen. Now, what happens if one or all 4 of these types of design don't happen? Yes, sir.
Basically, get a million people yelling at someone else trying to figure out, hey, can you do this, can you do that?
Right.
And we're going through that right now, where we're at. And we're trying to get those systems in place, like get the people involved, the process to get it down on the paper. It's a hell of a thing.
Yeah.
Especially in the remote company.
Yeah. Yes, sir.
I would say the biggest thing that happens is you get delay, and therefore the product delivery becomes a whole other thing.
Exactly.
You don't have all the stuff already set up to run that product through. And by the way, 2 weeks from now, you're going to run another minimum product through that same exact tunnel.
Yeah. Right. So delay. Now, I don't know about you. I haven't met many dumb, unmotivated developers. And we work with tons of client teams, and they're all smart, and they're go-getters, and they want to make things happen. So they get a feature, user story, PBI, whatever you happen to call them, a thing, a request, coming down the line, and they don't have all the information so that they can just continually work on it. They're going to stop. They're going to go have conversations. Is it with the right person? Maybe. They're going to make assumptions. They're going to think, oh, obviously this is the way that it should have been done. Here, let me just make it that way, right? They're smart. They come up with ideas fast. And so the conceptual definition, it'll be defined. They'll define it. They'll come up with what reasonable user experience, hey, if a new NuGet package or library seems to be, you know what, let's bring it in. And then how should this work from acceptance criteria? Those 4 types of design will happen. The question is, will it happen in an ad hoc fashion depending on who happens to be the coder of that thing on the team? Or will it happen in the way that the whole organization needs it to happen? Okay? But either way, it's going to slow down your process and it's going to bog up. Okay? Back when I was 16, I worked at a Taco Bell, and it was the perfect place because we lived in a neighborhood, but then a shopping center had started being constructed on the other side. And it turns out all I had to do was walk through my neighbor's backyard, and then I get to the Taco Bell's backyard on the other side. And so I got a lot of shifts because I could be there fastest. And of course, they're always having no-shows. Somebody didn't show up. Hey, do you want to come work? Heck yeah, I do. $4.25 an hour. Here I come. And so they have that assembly line. Well, guess what? If the person on the register doesn't say no lettuce and we put lettuce on a taco, have you ever tried to unput the shredded lettuce out of a bean burrito that's already been wrapped and packaged? No. So the customer says, this isn't what I expected, and you got to redo it because you can't unserve shredded lettuce. All right. Now in software, but we need these things will happen. They will happen at some point. The question is, for you and your team, are they going to happen at the place where you think that they should happen? okay? So I don't care what you call them. I don't care who does it. Just think about these different decisions and different workstations that need to happen, and just have that conversation with your team. Make sure that you've mapped the complete workflow in your team. And when you're creating your swim lanes in Azure boards, because I'm making such a compelling argument for Microsoft right now, when you're making your process in your swim lanes, make sure that you have every workstation outlined there. And again, I don't care what you call it. Call it whatever you want. Just make sure that that concept is there. All right, now we get to the developer. Developer codes up some stuff. It's probably a good argument in today's day and age for trunk-based development. By the way, does anybody use trunk-based development? Okay, isn't it interesting that if you go and read up on trunk-based development, the trunkbaseddevelopment.com, it's actually a website for it. With trunk-based development, every single day, feature branches are being created all the time. Trunk-based development has tons of branching. What a terrible name. I mean, just from a layman's perspective, right? So trunk-based development has tons of short-lived feature branches, and you do everything on a feature branch, and you actually do nothing on trunk. So you do no development on the trunk for trunk-based development. So I think it's an awesome name, obviously. But if we do our coding on a short-lived feature branch, and then run through with a pull request, then we do a build. Now I'm going to come back because we're going to have multiple dimensions here because we have builds actually running on feature branches. Then we do a build. Then we package up from the build to Azure artifacts. We're going to package up a release candidate. We're going to build once, deploy many. Okay? Build once, deploy many. We're going to package up a set of NuGet packages, that one for each application component, stick into Azure artifacts, which is our NuGet feed, our NuGet server, artifact server. And then we have a minimum of 3 environments, okay? And they're all going to be in Azure, all right, obviously. But there's no less. You will never have fewer than 3 environments in your DevOps pipeline. Okay, let me tell you why. Production. Everybody agree you're going to have production? Okay, good. No debate there. Now, back up from production. You need a manual testing environment, a manual validation environment. Now, in the days where you would provision and buy physical hardware, a staging environment was really important because if it was offside, in a virtual environment, the actual need for a dedicated staging only environment has kind of lessened because of how you can recreate and all that in virtual environments. But you need a pre-production environment where you can do any kind of exploratory, experiments, UAT, so call it whatever you want, but that second environment type is for any type of manual validation. Okay, now the third type is, and we call it the TDD environment because we don't want to, because there's all kinds of other environments, and if you call it a dev environment, people also have manual dev environments. The TDD environment, that is an automation-only environment. That is a no humans allowed environment. That is piggybacked off a continuous integration build. The CI build runs, packages up a new release candidate, and then automatically deploys it to the TDD environment. What's it validating? It's validating that it can actually deploy, and when it deploys, it actually starts up. And when we call the health check API, which every application should have a health check API, just like probably every car today has a built-in system health check that the mechanics stick the little dongle in, hit a button and says, oh, you got this wrong, here's a $99 inspection fee, thank you. The car just kind of checks itself and gives error codes. Does your application give error codes? So you need a self-check API. And then application starts up, great, and now we can run our automated acceptance tests, or any automated test suite that we might have. We might have an automated performance test suite, an automated Section 508 ADA screen reader compatibility test suite, any number of test suites that you could have that require a fully deployed application. That is the environment type for that, okay? So you'll never have fewer than 3 environments because you need at least 1 of each type. You can have as many of each type as you want, but you'll never have fewer than 1 of each of these types. Got it? Do you have a question?
So if everything is automated, why wouldn't I want all those actions to occur in the build process so that the build could fail before I ever had to do a deploy?
Good question. Because there are, and you want to shift as many things left as possible. You want to validate as many things in a continuous integration build as will fit in a reasonable time frame, most agree to 10 minutes. And I mean, and if there's other things that don't require a deployment and you get chain builds, those are semantics. But there are a lot of things that cannot be tested unless the software is actually deployed. And so that's where, okay, we need to deploy it. And the first time we've deployed it, now we can check more things. I mean, you could test every layer through component level integration testing in the continuous integration build. We've seen thousands and thousands and thousands of tests fit, in 5-6 minutes. So you can get a lot done in a less than 10-minute build. But for instance, full system tests going through the web UI, well, it's got to be deployed to a web server. It's got to be serving the actual HTML pages. And Selenium, it'll type in the text boxes, and it'll click on the buttons, and it'll navigate to the next page and all that. So that's same thing with screen reader compatibility. You actually have to serve the HTML and then run analysis on the HTML to make sure that it's descriptive enough so that screen readers can see. So there's a class there. But anyway, you can have, we've had clients that have 7 manual test environments for all kinds of different stakeholders. And then because we have so much full system test automation, it takes 3 hours to run. We then kind of break it up and just auto create 6 or 5 parallel TDD environments and run a portion of the test automation in parallel in different environments. And then when it's done, just destroy them all. And it gets that cycle time down for that stage in the pipeline. So you can fan out and have as many environments as you want, but never fewer than 1 of each type. Yes, sir. You can, yeah. Well, there's a comment, I think, right?
Yeah, because the comment is, we'll break down the amount of time to automate tests and just take the TDD and automate it to either expand out or contract depending on how many tests you have.
Mm-hmm. Yep. All right, and we get kicked out at 8 o'clock, is that right? Nope. What time?
What you got?
Oh, I could go all night. No.
8:30.
Okay, so let's keep going. All right, let's talk about, so again, we're talking about what needs to be in a DevOps environment when you have Visual Studio software, okay, end to end. And I know a lot of these ideas will go to other environments as well, but what do we need? So we've talked about the stages of work. And by the way, if you send me an email or a note, we can distribute these slides. And people are taking pictures. Unless you're taking a picture of me and tweeting it, which please continue. So this is a diagram for a model of how we organize applications in a Git repository. Now, 10 years ago, everyone would say, oh, well, where's your source code repository? Here it is. Here's our source code repository. Okay, where's the solution file? Which one? We have 200 applications inside this source control repository. And on the Microsoft stack, starting with Visual Source Safe, that's the way it was. Then even if you went to Subversion, a lot of times that's the way it was. You had a big Subversion repository, and you kind of subdivided it with directories, and you had lots of applications. Then changing over to Git, it really works well to put one built and deployed software system that has the same deployment schedule, one thing in a Git repository. Now, there's people that disagree with it. We've heard of Google's, whatever Omni repository, where there's one Git repository for the entire company. I don't know of a lot of companies that are doing that. What's that? Google
uses Mercurial.
Okay, sorry. One repository for the whole company. The monolithic repository. I think most people have the best time with things, and we advocate for Git. I think tons of people do this. It's very popular. Putting one software system in one Git repository. And so when we look at the relationship between things, then the model that we advocate has one software system that can be developed by multiple teams, And it can be subdivided into, it can be segmented into multiple versioned software applications. If you just think of a large system composed of multiple applications that can be deployed on different schedules, it can be segmented into multiple applications, but then one application resides in one Git repository. And of course, a Git repository can be owned by one team. A Git repository can't be owned by multiple teams because fundamentally, if they're separate teams, they don't talk to each other, they would be breaking each other. One team can have many Git repositories. And then now that you're inside one Git repository, which has one application, which means one Visual Studio solution, one application, which by the way could have multiple components. It could have an offline job or two. It could have a few websites. It could have a SQL Server database or two, all different components, but it's one application. It has one continuous integration build, software build configuration, okay? And that software build configuration in Azure Pipelines builds the one application that's in the one Git repository, all right? That's the general rule of thumb. That all of the tooling in the Microsoft ecosystem works really, really well when you stick with these conventions. Now, are there people who do other things? Yeah, but they have to do a lot of their own shell scripting and a lot of their own stuff because the tooling, the assumptions of the tooling kind of work different. All right, and I've actually seen, I've seen other platforms where this works generally well. So this is how we organize the source code, and the assumption is Git. All right. Microsoft has invested heavily in Git. The Windows source code is, I think, widely accepted to be the largest Git repository that we're aware, that the industry is aware of. And Microsoft has made some contributions to Git to actually let it support a repository of that size, which it didn't kind of when they started using it. And then, of course, Microsoft acquired GitHub, and so now there's just a lot more investment into Git. All right, so that's the code. If you look at the top level of the Git repository, our build script and our build helpers are going to be at the top level, and then the Visual Studio solution and all of the source code files are going to be one level down in that SRC directory. Okay, and I think that's a very common pattern with a lot of platforms. You put an SRC or a source directory, and then all of the source code goes in there, and the build assets and kind of helpers stay at the top. And the build.ps1, that's the private build script, and you can see some of the command lines around compiling and running the unit tests and so forth. All right. Now, we have, just to kind of ground the next few slides back on process, these are swim lanes. You've already seen this, okay? You've already seen this. Now, there's one more concept that is useful to think about. So sometimes it may be valuable to have a hierarchy. If product management thinks in larger features and you have screen mock-ups of larger features, but those features are too large to be implemented as a unit, and you need to break them up into user stories or whatever you want to call them. So sometimes it can be helpful to have a hierarchy where at some part of the process, normally when the lead technical person kind of takes a look at what's coming down the line, takes that feature as it's described and says, okay, what's the right unit of implementation? Let me break this feature up into maybe 5 different user stories, and each one of the 5 can be like, for instance, if you do an auto dealership software, and it's like and the feature is sell a car, you know, and they have these big flow chart and whatnot, but there's multiple screens that are necessary. You may break it up into, hey, this step of the process, this screen with the accompanying business logic. And so you take the feature and you break it up into multiple independently implementable user stories. And then you can specify the test scenarios for that particular user story. And then development can be fanned out and a user story handed to individual developers because they're all properly described. and then you can have your pull request and your automated test, your first line TDD environment, and all of that can be done at the user story level. And then once all the user stories of that feature, packet, or whatnot are all done, now you can get the stakeholders involved on their manual test environment and say, hey, will you test out this thing? Because here it is. Now, a lot of small teams kind of have conversations, and then they try to get their stakeholders operating from the beginning at the smaller unit level. But that's just a concept that you may consider. Okay. All right. So we talked about trunk-based development being heavy on branches. And so let's talk about the build lifecycle of a feature branch. Okay. So developer changes the code. Then we run the private build on the local workstation. Who here has read the 2006 book called Continuous Integration by Addison Wesley? Okay. Go back and read the chapter on, what's that?
By Jess Humble, Addison Wesley Publishing.
Addison Wesley Publishing, yes.
Jess Humble and David Parton.
Yes, I'm sorry. I mean, yes, correct. So there's no guy, yeah, there's no person named Addison Wesley. But the book Continuous Integration, it has a chapter called the commit phase, okay? And that is, and that commit phase, the biggest key elements that still exist to this day in the DevOps process, kind of unmodified from the original definition back in 2006, is the private build and the continuous integration build, okay? The private build is what you do before you commit and push the code to the repository. And so tools like Azure Pipelines and TeamCity and Jenkins, all these build products, what they kind of start people out on the integration build, and they totally leave out the private build because they let people have a build but have no build script that can run locally on the developer workstation. So the private build, you have to have a build script. So you have to write some little bit of PowerShell, and you're going to do a few things locally. You're gonna clean. Hold on a second. You're gonna clean the past build steps. You're gonna stamp a version number. You're going to build your database schema locally. You're gonna do a compilation, and you're gonna run unit tests and component level integration tests. And a lot of times, maybe it takes 2 minutes or 3 minutes locally, and that way you know you haven't broken anything big or obvious, and then you can push the code into the source control. Yes, sir.
That brings up some question. Over time, has the responsibility of DevOps team involved setting up local build environments for themselves, but also for back-end developers, API developers, even front-end developers, right?
Yeah.
You have single scripts that set up the entire environment, right? So that everyone can least run it locally, right? And then you have basic duplications and that augmentation and production builds. Like it's supposed to be, the 12-factor app principle, right? It's supposed to be every environment should only be an exact clone. I mean, close enough. But like I'm saying, having full DevOps eventually involved with those set of even local environments for everyone.
Well, I want to key off a few words that you said. You said DevOps team. I don't think that there is anything such. I go back to 2005, and there were a lot of recruiters who were searching for what these managers wanted to hire, and they were going around scouring, looking for these agile developers. I have 2 agile developer positions that I'm looking to fill. Anybody an agile developer? Oh, no, you're not. Okay. So now we're looking for DevOps engineers. What the heck is that? I mean, we're building software. We're not building. So I realize that lots of companies are just rebranding systems engineers as DevOps engineers and saying, now you need more scripting than you needed before. I'm sorry that you're not going to be spiking a hard drive because we went to Azure. They take away the screwdriver and you're no longer a systems engineer, you're a DevOps engineer. It is a hard problem right now because the industry is in transition. But to be effective, we really need organizationally to move to the cross-functional team where the team is producing working software. Like the original Agile Manifesto. Our highest calling is to deliver valuable working software for the actual customer. And then anything that we do needs to be part of that integrated team. And so, yes, the developer needs to have a suitable workstation environment whereby the appropriate private build steps, which are validations of what they just did, can be run. They don't need everything provisioned locally. They need enough of the environment so that they can have a private build, so then they can do that process.
I'm not saying that was great at any company I started. It was like, all right, here's your brand new machine, and if you run these local scripts, you start actually writing code.
I agree with you. There's other hands raised. So the full book will come out in May at the Microsoft Build Conference. It will have templates and a walkthrough of an entire Microsoft working environment with all of that. Because you're right. Few people have actually realized the dream. It's not hard once you put it all together and equipped with the right patterns and the templates. It's achievable. Every development team can have a working private build.
Sometimes you have to explain, even like, front end people, but sometimes they're getting front shells.
I believe you. I believe you. And
another question is like, shells are, they've been around forever, but like, what would something be like that everyone hated? Or Docker, yeah, that's true, but you still have the general Docker with the script. I mean, you're assuming that we still follow the instructions here. Follow these simple homebrew instructions to install.
All right, let me pull up.
Yeah, but those have to be installed initially. Again, if you're building them correctly, it's like you need a shell script, you can push all that out.
Okay, so
You can push all of that.
this is a .NET Core application running a private build script with a double click of the mouse, automatically creating a local SQL Server database schema from scratch, compiling, running unit tests, integration tests. In the Microsoft platform, there are most of the dependencies of what you need are installed with Visual Studio. It's a pretty big integrated development environment. And then NuGet sources a lot of your libraries, and SQL Server Express or Developer Edition can be installed locally and provides you the full database environment, and it works really well together. And I think this.
I'm saying like some people, some
There it is.
touch the command line to begin.
You're saying the organization won't let them?
No. So some have never some of the more junior people.
Okay.
Like if you're trying to bring in someone like that.
Yeah. Sure.
And without just giving here, read this, put these commands into your command line. Like when they get a open a command line. I know that sounds insane, but with the way that some of the developers coming out.
Oh, totally. Yes. Well, remember that chart. Over 50% of the developers, are real in the industry are really young, and so as we're looking to equip our team, they're not going to have those skills, and so we need to equip our whole team with a hit enter or double click on this to run the private build. Instead of, hey, you need to invent your own private build. Oh, we're putting it in source control right next to the source code. So somebody on the team needs to be able to do that, have the skills to do it, and then the whole team is equipped. And yeah, some of the people, guess what? You're the HTML graphic slicing CSS person, and you just make it look pretty. We'll give you the private build script to make sure you don't break any of the other code. I mean, that's fine.
I know, but then you wonder, is there any tool but script?
At some point, you have to train people. So if you're going to hire junior people, you have to commit to training them. Just to say you don't know something, therefore we have to re-engineer our entire environment is neither efficient nor intelligent. So you have to make the commitment at some point to say, all that 57% of the peoples, yeah, those are the 57% of the peoples we got to train. Because if somebody can't type big enough, I'm not going to hire them.
But they're smart. They're learners. We just have to show them. We have to bring them up.
So what does that look like in practice with customers that you've seen? Because I've been working in the enterprise cloud space for a long time, and I don't think I've ever seen a development team that has like a sysops person embedded in the team. There's always that silo. Now, granted, people I've worked with aren't that advanced, but some teams work. So what does that actually look like in practice, and how do you get an organization to change it by saying, okay, we're going to get rid of the ops manager, we're going to get rid of the dev manager, and we're going to put everybody, smash them together in one big team?
Okay, good question.
You can spin up teams for projects together. As an ops guy, I sit with one dev team for 6 months while we're doing a project, and once the CI build and that automation is kind of complete, that's where I can kind of go off and work with another dev team for another project. And I may come back and I have an idea to fix something or do something. and keep in touch, but I don't have to sit on that team the whole time.
Yeah.
I've also had the experience where the ops people build this process with developers.
No, I've been that ops guy just like him. The way I like to conceptualize a lot of times is you need to train them to a point to be able to accomplish a certain job or whatever the mission is. So you just need to understand what the mission is going into it, understand the skill sets that are already there, get them up, fill that gap. And yeah, then that team owns it. And that team can be amorphous. Like I work with companies where as an individual, you're a member of 2 or 3 teams. Usually the more senior you are, the more experienced you are, the more teams you're a member of. A lot of those older teams, they don't really need to interface with that application because they're just in the back end running. So they're going to take on new responsibilities. It's all about building that culture of learning, of growing. If in this industry, if you're not constantly pushing yourself and learning and stretching yourself, you're not going to make it. I came from sysadmin background, so but I work with devs like all the time. I've been in your spot where like I walked in and I'm like, what do you need to know for loop or like a dashboard or something. And yeah, like that's my responsibility is to sit down and get them that skill they need to get to the next step. You're a force multiplier, if anything. So you're really trying to take all that knowledge, experience you have, and just build into them. They may not understand all the nuance of what's going on, but if they can accomplish that mission, then you did your job. And that's what I was trying to do.
Can I ask, do you consider yourself kind of a cloud architect, and then people that actually get dropped into a team, are they automation engineers? I just had lunch with one of my friends who moved from my company to this other company, and he was kind of explaining how this process worked, and I'm like, that's interesting. You still have an ops team and you still have a dev team. I wasn't saying they're doing anything wrong, but
yeah. The whole having a title thing, for a lot of confusion on it. I've been a cloud architect, I've been a DevOps engineer, I've been a sysadmin. I've done the same job in all those places. My title is different. My pay went up. But yeah, so like, when he was talking about building that architecture blueprint, I came into a company and I did software archaeology and I built a blueprint retroactively, so we were able to move forward. I've been in that dev team and been the operations guy and built the pipeline for them and then trained them how to use it. I've been there and just ran lessons out for the team and had them build it themselves. Like you really, again, don't get something up on the title or what the tool is or any of that. Identify the mission, identify the gap, and then be that force multiplier, fill the gap so that you can free up your time to go and do the next most important thing.
Yeah, I think conceptually I understand it. It's more breaking. How do you convey that to management, existing management structures? People are afraid they're going to lose their job. That's the real trick that I struggle with in every single customer engagement for people who don't get it.
So let me give you. There's a lot to unpack in what you said there.
Yeah, sorry.
So let me address what Chris was saying earlier, because this is super cool. In every situation, and Jeffrey brought this up several times, right? When you go sit down as an embedded engineer, the first thing that has to happen is negotiation. You have to say, where does it end? I always want to leave with the development team responsible entirely for their build, but not for the deploy necessarily, right? So that's that's where I want to start with the negotiation. So, that becomes a skill set question, right? How much can I hand off to them? Just because I want them to learn doesn't mean they're going to, or they're going to fast enough. So there has to be a negotiation, usually at one level up from where the engineers are, between the managers and their lead engineers. So the other thing is, I'm at a very large database company right now with a client that is not Microsoft, who happens to be building their own public cloud. And I am actually doing DevOps training, 8 hours worth of DevOps training for their global project management, because they just broke up their entire system administration team, deployed these people, and embed them by force into the. Well, there are 40 project managers, and I think they said 1,700 development engineers in total. Developers, ops, QA, software. So I'm just training the project management team thinking in what is DevOps, so they can speak the language, if you will.
Yep.
So I wish they were all here listening to what you were talking about right now. Well, I've only done the first 2 hours.
It's great because this is being recorded. It's going well.
How's it going for him?
So it's actually, so we've only done the first 2 hours, and it was stunning how much, you get a lot of people like this, virtually, of course. And by the end, everyone was leaning into their camera. Yeah, so they were and their questions were, okay, I've got this guy who doesn't want to change. He's a sysadmin. He doesn't want to be a DevOps. What do I do? Right, so I ended up fielding a lot of questions like that, and I will field those again next Thursday as well. So ask me in a month, and I'll be able to give you we can do that as an open space in May if you're really curious.
So in 2006 and 5, when Scrum was really starting to take off, lots of people were getting Scrum Master certified. I taught Scrum training. I mean, I'm a certified Scrum Master. I guess I would be if I'd have paid the money all these years to keep it active. But it's the same thing. It's you're moving people's cheese. You're saying do it a different way, and so that wave is happening again because the same wave that kind of Scrum did. But hey, you know what? Let's not do things in 6-month planning cycles. Let's do really small cycles. And we're moving everybody's cheese. Well, the same thing's happening again with environments. No. I don't need to tell you the environment specs now. We'll get to that later. Well, wait a minute. So I brought up Microsoft's engineering system. They did a whole write-up in how Microsoft converted from having test team, PM team, ops team, all this to being one team that was responsible for running their system. Now, not every part of Microsoft is organized in the same way. Different parts are moving at different elements, but the Azure DevOps services team with Azure Pipelines, all the planning tools, they were one of the first movers, and they've documented their whole journey with not just text, but also video walkthroughs and shifts in responsibility. They took every one of their engineers in test and said, we have no yada yada engineer. We now have 2 roles in our 800-person organization. We have a program manager and we have an engineer. Which one do you think you're interested in? Would you like to think up what we might do, or would you like to do? And those are the 2 roles they settled on. And yes, there were a lot of people who were testers who did not want to or could not transition to being an engineer, and they left the company. It was a hard transition. And all the ops people, either you became an engineer or you left the company. Now, it's such a big company, some of them transferred to other parts. But with Azure, they've really taken all of their ops and all of the dedicated ops, it's kind of in the Azure group, running the Azure data centers. You know, everybody else is kind of putting their software in Azure. But anyway, let's see, what's the URL we can get to, and then anyway, there's tons of videos. If y'all would like to go through all the politics that they went through, it's all here, and it's actually a fascinating story. So the URL is stories.visualstudio.com/DevOps. Stories.visualstudio.com/DevOps. Because yes, besides the technical stuff that we do, there's a lot of human stuff. All right.
I mean, on your daily basis.
So our target market are the people who want to implement DevOps. They've made that decision. And so it's a higher percentage of us putting the capabilities in place rather than convincing them. Because we are a professional services company, we come and we talk to the people who've already made the decision that they want to do it and they have the momentum in their organization, rather than us going in and attempting to convince. Because of that, we're a higher percentage of actually getting in place what's necessary with a more willing crowd at our clients. So that dynamic is in play. I recognize that. And I do empathize. But I don't want to take you too long past midnight, so let's keep going. So we have the private build on the feature branch. We commit and push, and then on our feature branch, we have the integration build. We have the continuous integration build executing on our feature branch, because we don't want our code messing up master if it's going to fail the integration build. Not just that, but once the continuous integration build fails, then that build from our feature branch is then packaged up as a release candidate, and it's marked from a feature branch, so it's never going to make it to production. And then it's deployed to our TDD environment, our automated acceptance test environment. And then those full system automated acceptance tests are run against a fully deployed instance of our build that came from the changes we made on our feature branch. And if any problems are found, guess what? We're not ready for a pull request. If we don't do all of those steps, we have more surface area where a problem could slip through when we submit the pull request, and then what if it passes, inspection and then gets into master, okay? So once we go through those steps on our feature branch, then we can create our pull request because we baked in a lot of robustness into the steps so that we have confidence that we're ready to get those changes moved back into master, okay? Then,
hey Jeff, are you sharing a screen?
Master branch, the pull request is accepted, the top left. So changes from the branch merged into master. Great. What happens then? Well, after the automated merge, which is all the pull request tools use, and Azure Pipelines has and Azure Repos has a great pull request experience. Then the continuous integration build happens again because we have put change sets into master, which, by the way, master could have received changes from another branch in the interim. Again, these are short-lived branches. And by the way, if we have a branch that lasts more than a day and into the second day, to keep ourselves safe, you want to back merge from master into your feature branch several times so that the diff stays very, very small. You don't want to get too far away, okay? Then CI build happens on master. Then, now we have a release candidate from master. So hey, guess what? That one could be the one that gets to production if it makes it all the way through. It gets deployed. Then the automated acceptance tests happen again on the TDD environment because we have a different build. And then after it gets past the TDD environment, at that point, we could say that we have, you know what? We just might have a viable release candidate that could go all the way. It could go all the way. All right. So now let's look at continuous integration build steps. What the important steps are. I know this is a little bit small. Let me just walk through here. So,
hey guys, are you trying to show us a slide?
Just like test and development, I have 3 columns here at the top. You can't read it. Arrange, act, assert. All right. We set up some stuff, we do some stuff, and then we check some stuff. Think of that's a continuous integration build process. It's a continuous integration build. It's a test. We're going to check something or a lot of things. So we're going to clean any ancillary files. We're going to delete the build directory. We're going to delete any temporary stuff. Then we're going to stamp a version number. That version number that's stamped there carries through all the way to production. All the NuGet packages get stamped as that same version. Then we are going to create or migrate database, which in an integration environment means we're going to create our relational database schema from scratch. We're going to create our SQL Server database. All right, now that's setting up. Next step is we're going to compile. We're going to msbuild.exe or .net.exe. We're going to compile all this code. Then we're going to start asserting. And so we are going to run our unit tests. Then we're going to run our component level integration tests. And then we're going to come here in the CI build. Once we've done all of our asserts, then we do extra stuff that we did not do in our private build, okay? Because it's on the continuous integration build server. We're going to do some extra stuff like all the static code analysis. We can parallelize that. We're going to publish our test results so that we can keep track of them. Then we're going to package it up into NuGet packages that are deployable. And then we're going to copy the NuGet packages up to Azure Artifact, which is our NuGet view.
Why would your test in other environments be
They are. So yeah, good point. When we deploy to our TDD environment, we're deploying our acceptance test suite that has been packaged up as a NuGet package stamped with the same version number. In the continuous integration build, you can kind of run NuGet straight from the same files that you did your compile. So it's not really necessary to do a packaging step for the integration build. But once you deploy, yeah, any test suites that execute on a deployed environment are also deployed. Is that what you're asking?
Yeah, I was just trying to figure.
misunderstood it. I thought you were going into the final media package at the end, but I realized just put extra components in production.
Okay. Yeah, this is the continuous integration build, and we run unit tests and integration tests during the build process. We package up everything that might need to be deployed, including any downstream test suites that need to be a fully deployed environment. Okay. All right. This is our defect removal process. Now, it's just kind of labeled a little bit differently, but you've kind of already seen this flow. But we could have defects in design and validation. These are the activities that happen by those people if they're different. And then these are the activities that happen on engineer workstation to rid us of defects. This is the activity that happens on the build server to find defects. And these are the activities that happen on the TDD server, or TDD environment, to find any defects. Because we can find problems all over the place, and so we need to have tactics and strategies to find them in all kinds of different ways. This is this is Azure. This is Azure repos inside Azure DevOps services, and this is what it looks like to do a formal inspection inside of a pull request with Azure repos, with Azure DevOps services, where you just have check mark, and it could be as simple as that. And someone is saying, "Oh, you know what? Our team has all these categories that need to be checked. And, there's standards and conventions for the standards around each one, but that way, everybody who's doing a pull request, and you determine who is a qualified inspector, because probably a junior developer who just started yesterday might not yet be a qualified inspector. So you decide who's going to be a qualified inspector, and then there is the checklist. And so they go through and they know how to check everybody. Check. And guess what? If it fails any particular one, you can make comments, and then under approve, you can say, wait for submitter, and you can kind of put it in a holding status and wait. And then they can make changes to the code and put new commits. And you can create, by the way, you can create this pull request at any time. And then you can add commits, because this pull request is not for a certain set of commits. It is for whatever commits are on that branch. And then when you hit approve, everything that's there gets merged in. So that's kind of how it works. You don't have to reject the pull request and then create a new one, and then lose all of your journaling and comment history. You can actually kind of put it on hold and say not yet, and then add some more commits to it, which I think is kind of a nice feature. All right, release candidate packaging. I think we've already talked about this, but this is kind of how, illustrating how the deployment in every environment reaches over to the Azure Artifact service that Microsoft runs for us, grabs the packages, and then uses them to deploy. So we build once and deploy many, and every deployment configuration goes and gets a particular version of packages for a release candidate. Yes,
I've been stealing your slides from the screen share.
Sure.
But the screen's blacked out. So there are a couple of guys that are on the call that are complaining about it.
Okay, let me see if I can fix that. Screen. Okay. Okay. All right. Thank you very much. I appreciate that. All right. So let's wrap up in about 5 minutes. Okay. Now, packaging for deployment. Let's say that our application has an ASP.NET website, an offline job, and SQL Server database, and then it has an acceptance test suite with Selenium. You have that architecture of an application would have 4 packages to make up a release candidate. They'd all have the same version number, but you have 4 packages, meaning 4 NuGet package files, .nupkg. That's the NuGet package file, right? That's the equivalent of the node npm file. So the UI, the web application will go in one, the offline job in another, the database schema with requisite migration tooling in another, and the acceptance test suite. You have 4, and then you package them up. All right? This is what it would kind of look like in Azure Artifacts on the screen. When you look at the feed, you can see the 4 files, when it was last pushed, and if you pull one of them open, you can, kind of like exploding a zip file, you can see the contents. Okay? This happens to be the contents of the database migrations or database deployment package. And who here automatically deploys database changes unattended? Anybody? Okay. Just last week, we did a joint webinar with the Octopus Deploy CEO and founder, and it was about automatically deploying databases. That has been recorded. It's on our YouTube channel. Go check it out. DevOps is anemic unless your database is not deploying automatically along with the application, because you're kind of half manual, half automated. We package up things like changes as SQL scripts. And essentially, we don't change a create table script. We make a new script that is alter table add column. And so if you run 1,000 SQL scripts in order, you will end up with the same schema because everyone is an alteration. And if you were to need to do a hotfix of your release from last week, you go into your Git repository, go back in time to a week ago, and guess what? You will have fewer SQL files, but you run it, and you get the exact SQL Server schema as it was a week ago, and that way you can do the hotfixing and your build works and everything like that. And when you do a hotfix branch, your integration build is running on that branch, executing the tests and the schema from that branch from 2 weeks ago. Okay, so that's kind of the gist of migrations. All right, we talked about 3 environment types. These are the things and the differences of the 3 environment types. Again, you can have as many of each type as you want, but you'll never have fewer than 1 of each type. And so the TDD environment, you see you have a lot of automated things. The UAT has manual things and a few less, and then of course production. But you notice that each environment has the health check. Each environment has the health check. By the way, the IT monitoring tools often accept a URL that they can kind of ping on a schedule every few seconds or minutes, right? Everybody uses those? Okay. So it's as easy as this. Make a web page or an API, REST API that either returns HTTP 200 or just returns a word, success, on the screen, and then write a few lines of code to tickle your key dependencies. Like write a select 1+1 or select top 1 from common table of your SQL Server database. Well, that'll make sure that the connection string is right, that you can reach the SQL Server database, and that it's online and responding. Because guess what? Your application can't do much if it can't talk to the database, right? So that's a way to tickle your database. Let's say you need a network share to write exported PDFs or Excel files or CSV files. Well, can you even access that network share? Write a few lines of code to tickle that dependency. The lines of code would fail if you can't get to it, okay? So just think about all the ways your application could fail, what dependencies it has, and write a few lines of code to tickle that dependency. And guess what? You're making sure every time that URL gets pinged, it's just kind of tickling the different dependencies. It's a much richer I'm online response than just the web server happens to be responding. It's a way for that to go deeper. All right, so we started with this. We're ending with this. This is the DevOps process end to end. Again, it doesn't start with code. It starts when you're thinking about what to do, and then it ends when you're operating and supporting and have centralized logging. Here are some samples. If you want a working .NET project, you can go to these URLs. You can have the slides, obviously, so you don't have to write that down now. And here's my contact information. I'll be happy to stay and answer any questions. I appreciate your attentiveness and the discussion. So thank you very much for having me.
Thank you very much, Jeffrey. We are not going to stay here because while Chris likes us, he loves his girlfriend. That said, did you all notice an Easy Tiger just up the road at Lincoln Center?